So the last force that we're going to talk about in this unit is the drag force. And this is another one that I think can best be understood by an example. So let's say that we have a ball that's falling. So it's going to fall toward the ground. And initially at time t1, let's say that we haven't dropped it yet. So it's just, it's like the split second after we've let go of it. So we know that there's going to be a force of gravity acting down on the ball. Okay? But then after it's started moving a little bit, it's going to have fallen a little bit toward the ground. Again, we'll still have the force of gravity acting on it. But that's not the only force anymore. Now, for most of this class, we're going to neglect drag, or air resistance. But we should still talk about it so that we understand what it is and how it comes into play. And so let's think back to one of the first videos when we saw an astronaut dropping a hammer and a feather on the moon. And we saw that when he dropped both of them, they both hit the ground at the exact same time. But of course, if you went to your closet right now and got out a hammer, and you went and found a feather and you dropped the two of them, we know that the hammer is going to hit faster on Earth. And the reason is because there's another force, and that force is a drag force. It's the air resistance that's pushing back upwards. And so this is from the air, that's that's preventing the feather from falling more than it's preventing the hammer. Okay? But again, like a frictional force, it's only this is more kind of like the kinetic frictional force, where this force is only in act when the object's actually moving. So so at the first time when it wasn't moving, there's no drag force. And the second time there's a drag force. A little while later, the ball comes and collides with the ground. And then in this case, again, we have a force of gravity. There's no drag force because the ball isn't moving, but there is a normal force from the ground acting up on the object. And then a little while later, once the ball is moving up in the air again, you have a force of gravity acting down on it. And now you have a drag force, but now the drag force is pushing down on it because the ball is going up. So you have the drag force pushing back on it. So drag force is always it's opposite to the direction of motion. And in one of the later chapters, we're actually going to see how to calculate drag force for different objects. So that wraps up this chapter. So now as you're preparing for the exam, this exam is basically just going to be drawing free body diagrams. So you're going to need to make sure that you have a lot of practice at drawing these. So what I would do is I would look at a lot of the problems from your book even in the first book, and draw free body diagrams for those. And I would look at, and make sure you also look at chapter 2 of the Newton's book, because circular motion is another thing that we might be talking about sometimes, and that might show up on the exam in free body diagrams. So just make sure you have a good concept of that, and that you get a lot of practice with those, because that's all this first exam is going to be, is just drawing free body diagrams. And you really have to get them all right to be able to move on to the rest of this book, because this is such a fundamental part of understanding motion, is understanding the forces that are acting on an object. And I see students finish an entire semester of physics, that some of them even making a C in the class, and they can't draw a simple free body diagram, which means they're basically not getting a single problem right on the final exam. They're just kind of relying on some partial credit to get some to get whatever grade they get on it.